All right, let's take a look at this next example. Once again, we're trying to solve this system by using this new technique, elimination. All right, and so here's the process we go through. First off, we look to see, does everything line up? In this case, I'd say yes. X's line up, the Y's, again, a key thing, the equal signs have to line up, and then these numbers on the right line up as well. All right, so now that that's good to go, we then ask the question, all right, well, what here matches? I'm hoping you're looking right here, 4y and 4y. Now, I chose this example because it's different from the last one, okay, and I want you to make note of that. If you look up in your notes, and you're looking at this example, right here, we noticed that negative 5x and positive 5x matched. And so the decision we made was to add these two equations together because that's what would make all this disappear, so we'd have nothing right here. Okay, so the same decision making is going on here, but it is a decision you need to make. Okay, in this case, the decision is I have positive 4y, and in fact, let's just cover up the rest of it. Positive 4y and an identical positive 4y. So the decision you need to be making is, should I add or subtract these equations together so that these matching items are eliminated? Okay, so if you think about it, in this case, unlike the first example, addition doesn't work because positive 4y plus positive 4y would create 8y, and we haven't made it disappear. The whole point was to make these disappear and eliminate them from the problem. So in this case, the decision is to subtract. So over to the side, we put a big subtraction sign. And what we're going to do is we're going to subtract the bottom equation from the top one. So go column by column. 3x minus 7x would be negative 4x. I'm just going top minus the bottom. Okay, and here's the important decision making and the reason why we made it. Positive 4y minus positive 4y is 0. So this is now eliminated from the problem. The equal signs drop down, and now be careful here. This is where people make the common mistake all the time. Even though we're working on the right side, we have to go back to this. It's this entire top equation minus the entire bottom one. So what I do is negative 6 minus negative 14. Negative 6 minus negative 14. I always go back, and that's why we circle it nice and big over here. That would turn out to be positive 8. All right, and once again, this is the goal that's been kind of consistent throughout these couple of different methods. I go from two equations with two variables down to one equation with one variable, and we know how to solve this. Divide by negative 4, so x is negative 2. All right, so there's half our answer. X is negative 2. Just got to go back and find y. And once again, we use this. This becomes a substitution equation for us, that x is equivalent to negative 2. So we go back to one of the original equations, and everywhere we see x, we're going to swap in negative 2. So once again, it doesn't matter which of these two equations I go back to swap in x equals negative 2. So you pick whichever one's easier. I'm going to go with this top one just because it seems to have slightly smaller numbers. So again, I do what the substitution tells me to do. Everywhere I see x, I'm going to swap it out, and in its place, I'm going to swap in negative 2. That's my substitution. So I'm going to do 3x plus 4y equals negative 6. And in place of x, we're going to put in negative 2. 3 times negative 2 is negative 6. Start solving the equation. Get rid of the negative 6 by adding 6 to both sides. 4y equals 0. So if I divide both sides by 4, y equals 0. All right, so there's the other half of my answer, that y should be 0. It's the one xy pair that should work for both the original equations. It's the one place where these two lines on a graph should cross. All right, so as always, let's check our answer, make sure we did it right. I think I'll take the top equation, this one right here, and I'm just going to put it in blue. So 3x plus 4y equals negative 6. And in place of x and y, I'm going to put negative 2 and 0. 3 times negative 2 is negative 6. 4 times 0 is just going to disappear. So we get negative 6 equals negative 6, and it checks out. So then I'll take the bottom equation, and again, it's got to work for both, so I need to check the other one too. Can only check one of them. 7x plus 4y equals negative 14. And in place of x, negative 2. In place of y, 0. 7 times negative 2 is negative 14. 4 times 0 disappears. Negative 14 does equal negative 14, so we did everything right. All right, so this would be the solution to our system. It checks out in our system, and so that's the process of elimination.